Oh, okay. So let's start. Also, welcome from my side to another EclipseStore fundamental training. Yeah, let's directly step into very important information first. This training will be recorded, and you will also get access afterwards. Normally, it takes us, 4 to 5 days to cut the video a little bit and then send it to you or send the link to you within an email together with some other informations. Yes, so about me and my colleague, my name is Kuemmel. I'm a Java developer for around 18 years now, I would say. I'm a project manager of the MicroStream cluster development, and I'm also involved in some other MicroStream or EclipseStore projects within different companies like Allianz and Fraport, the German airport company. And most of the time, I'm also on some trainer and conference speaker also. So that's why I am here. So I think Marcus will introduce itself later because he starts with a small EclipseStore basic introduction directly at the beginning. And that brings me to the timetable for today. So normally we start at 5 till 9. So with a small break somewhere around 6:30 and 6:45 Central European time. And just for coffee and some other things. Let's go through some more detailed information. So as I said, material you will get after the training. One important thing is ask as much questions as you can. That's why we are here. I have planned enough time to answer it. That's okay. So some links I want to share with you. So just a second. So, and I will also copy paste these links to the chat. Give me just a second. So here's a list of different links we will use during the training. So let's begin at the GitHub things. So let's start at my GitHub account. This is where all the most projects will be there. And I will share every link to every project for each topic with you so that you will be able to, maybe code along with me or have a look after the training. So the EclipseStore documentation is also a very important thing to work with EclipseStore. And of course, there are a lot of other bigger projects and examples available on EclipseStore GitHub. Feel free to check it out. Last but not least, you will get a certificate. Also around 4 to 5 days after the training, it will be available within our cloud platform. So that means when you sign up on our platform with the same email address you take part today's training, then let me just share this. So this is the platform, and just sign up here, and then there is a certification section here on the left. And if you registered the right way, you will see here your certificate. You could download it and whatever to do with such a certificate. Okay, let's go straight into the topics. So as I said, there is a small EclipseStore introduction by Marcus direct at the beginning. Then we start with a quick demo, just an easy step in from my side. That's the moment where you still could lean back and just listen and watch the code. Then we go through a step-by-step configuration of EclipseStore. That's the part where you could code along with me and we could do it together. So I would share your project with different branches in it and so on. And we will create a project directly from scratch. Then we have some additional projects, especially for CRUD operations and advanced storing transactions and so on. And then two interesting parts, which were normal parts in the previous trainings. So that means creating a proper data model and also querying with Java Streams API. And I'd like to skip this a little bit. So I will do it in a different way within that training. On every step you see here, I will add some smaller things regarding these topics because most of you are aware of Java Streams and also what a proper data model means. But no worries, I will tell you how to create a good Java or a good working data model for EclipseStore. But some more interesting topics here is the usage of lazy loading, because in the past we have a lot of questions from our customer, how to use it and what is the best practice of using lazy loading and so on. And that's why we added the lazy loading again to the fundamentals training, because it's an important part of EclipseStore. And in the same way, then the GigaMap collection, which is also, I would say, new to the fundamentals training, but it's a powerful component and you should always use it, or you should use it, or you should be aware that the GigaMap collection is there and can be used, and also the LegacyTypeMapping. And then we covered all the most asked questions or fundamental questions of EclipseStore. And yeah, enough information to start right away with EclipseStore. Okay, so that's all from my side so far. So then I can hand over to Marcus. Marcus, are you ready?
Absolutely, Christian. By the way, let's do a small sound check. Is my audio okay, or is it too noisy here?
That's okay.
Okay.
No background noise from your side.
Astonishing, really astonishing. Okay. So welcome everybody, and thanks for joining us tonight. Welcome to our EclipseStore Fundamentals training. This fundamentals training is today broadcasted from Morocco. So we are here at Devox Morocco, and I hope the sound is okay. So I found a room where I can do this introduction. So this introduction is about EclipseStore, and it's an introduction to the fundamental principle. It's a functional principle. So if you have any questions, please use the chat, ask your questions, and Christian and I will try to answer your questions. So EclipseStore is an open source project, and we started the project almost 10 years ago. You can find all information on the EclipseStore website, and on GitHub you can find the code, and you can also find the code of Eclipse Data Grid. So EclipseStore is the storage engine for storing Java object graphs on a single JVM, node. And with Eclipse Data Grid, you can now also build distributed applications using EclipseStore. Distributed applications or microservices. My name is Marcus Kett. I'm CEO and co-founder of MicroStream. And together with my team, we are working on open source projects for a long time. We have been working on Java development tools and database tools for almost or more than 10 years. And now we are working on Eclipse Data Grid and EclipseStore open source project. So we are also very active in the Java community, and so maybe some of you guys have seen us at met us at conferences. We are also a member of the Eclipse Foundation, and within the Eclipse Foundation, so we run around 100 open source projects. So Eclipse is not only famous for the IDE, but also for many open source projects, and also the standard, so Jakarta EE and microprofiles built within the Eclipse Foundation. And there are also very interesting projects like the OpenJ9 JVM that is fits great with EclipseStore, by the way, because it's very memory efficient, and so it's a very powerful JVM you can check out. We're also contributing EclipseStore to Micronaut. So EclipseStore is part of Micronaut, and so we contribute to the Micronaut project, and we are also a member of the Micronaut Foundation. So let's go through the functional principle, and for both you guys who are new to EclipseStore, what is actually the purpose of EclipseStore and why using EclipseStore? So when we started developing tools for database programming in Java, we had the challenge that the performance was always not really great. And developing or database programming in Java was very complex for our users. And so the big question is, what actually is the fundamental problem of database programming in Java, or in general with object-oriented programming languages? So it is the data structure. So it's a completely different technology, actually. So Java is, from a technical perspective, incompatible with databases, because you cannot store native Java objects in a relational database. This is not possible. So there are many impedance mismatches here. And it's the same with NoSQL databases. They introduce new data structure or formats, but they are also, from technical perspective, incompatible with the Java object model. So you cannot store native Java objects seamlessly in a NoSQL database. It's not possible. So to solve this technical problem, we use object relational mapping for relational databases and data conversion for NoSQL databases, like JSON conversion. And the problem is, for storing objects, we need this data conversion or this object or relational mapping through every single read and write. And the same when we receive a result set from a database, we cannot receive Java objects. So Java objects has to be generated behind the scenes through every single read and write. And this leads to higher complexity, and it leads to latencies, to very expensive latencies. And because of these latencies, we mostly are used to use caches to accelerate the performance, the database queries. So we are used to use local caches. And by introducing a local cache, we increase the complexity. So it gets more and more complex. It's just because we want to store some data. And it's even more complex when we build distributed applications. So with distributed applications, for instance, we have challenges in terms of consistency. So imagine you have an application running on multiple nodes, and on one of your nodes, data will be changed, and you store the changed data in a database. Then your node will be in sync with the database. But all the other nodes will not be in sync with the database. So here you have to change your cache strategy. And this is also common. That we put the cache between the application and the database, and use a distributed cache between the application and the database. But as you can see, the complexity increases more and more. And every single box here is a server. So we need more server nodes, we need more CPU power, and we need more memory, of course. And if you have higher load on the database, or you want to run a high available database, you need more database nodes. And then you add more database nodes, it gets more expensive, of course. You need more machine power, you need more memory. And then with microservices, it gets even more complex, because with microservices, you have multiple distributed tiny services. And then in practice, it's not enough. Even if you have a powerful database, in many enterprise projects, search servers like Elasticsearch are used. And so you need another solution for processing your data. And then we have even multiple database systems, and it's because of with Java we are able to process any kind of data. We can deal with everything. Databases introduce a specific data format or a data structure, and so they are really built for a specific use case. For instance, if you have unstructured data, maybe you will use a NoSQL database like MongoDB that's suited for unstructured data. If you have very complex data, maybe you use a graph database, and so on. So multiple database types for different use cases. And the architecture overview gets more and more complex. And you can see a lot of machine instances are used with many CPUs required, and with a lot of memory, and memory is very expensive. So the question is it possible to simplify all of this? And with Eclipse Data Grid, we did it. So because we believe with Java, we can simplify data processing tremendously. So how should this work? So with Java, we have a very powerful, not only language, we also have a powerful platform or runtime, and everything that is executed in Java in memory, it will be extremely fast. So we talk about microsecond access time, microsecond lookup time, microsecond query time. So in comparison to a database where we talk about milliseconds, and we compare milliseconds with microseconds. So put your calculator, it's 1,000 times difference. So memory, if you access memory, if you process data in memory, it will be 1,000 times faster in comparison to a database query. So everything that can be processed in memory with Java will be extremely fast. So let's use the performance of Java. And we have with Java, we have a great data structure. We have objects. We can build object graphs. So we can define our object and our data model freely. You cannot use just list. You can deal with collections. You can build complex graphs and with circular references. So everything is possible in Java, and you can also deal with any data types. So that's great. We have a multi-model data structure. So while the databases are looking for the holy grail, building multi-model databases, in Java, you have it from the beginning. So let's use it. And what about searching and filtering? We have the powerful Java Streams API, where we can search and filter in memory. And this will be extremely fast. So you should check this out. whatever you do with JavaStream's API in memory, it will be executed in microseconds. And this is extremely fast. So use this performance of Java for your data processing. So I mentioned OpenJ9. Of course, you can choose your Java virtual machine freely. But so when we talk about in-memory data processing, OpenJ9 is very powerful, and we have measured. So because we have to test EclipseStore with all JVMs, so we found out that the OpenJ9 JVM is highly memory efficient and very fast. So check this out, and even the Java version is deciding. So we found out that the latest Java versions are faster than old Java versions. So you can accelerate your application just by updating the Java version. That's great. So use this opportunity. So I was talking about core Java features and the power of Java. But what's missing in Java is you cannot store objects. This is not possible. So and now with EclipseStore, we added persistence to Java. So now with EclipseStore, we have now an engine, a storage engine that is able to store any kind of Java object graph, any size and any complexity persistently on disk, and restore it in memory when it's needed. And this is what EclipseStore brings on the table. So it stores your Java objects. You can design your object graph freely. Design whatever you like, whatever is possible in Java. Use circular references. You can use inheritance, whatever is possible in Java, and you will be able to store it with EclipseStore. The cool thing is that EclipseStore does not store your whole object graph. It mostly stores just the changes on your object graph. You can store subgraphs, and it can restore subgraphs in memory. So you can use lazy loading. You never have to load your whole object graph in a memory and restore your whole object graph and your whole database. You can use lazy loading for just loading tiny subgraphs and load data in memory when it's needed. And to use EclipseStore, this is very simple, and it's because of it's fully object-oriented. You have your object graph. You just have to call a get method, and for instance, a get customer, and then the storage engine will load your customer object from disk and merges directly into the object graph. So it works like magic. So there are no more classic selects like you have to deal with in a database system. You just call get methods, and it's fully object oriented, and EclipseStore will load the object references into the memory, and it stores the objects into the memory, and then the JVM takes control of your object, and this is, yeah, it works like magic, and it's very convenient. So when you store an object, then EclipseStore will create a binary representation of your object. So we use serialization for creating the binaries, of course, but here at this point, we do not use the traditional Java serialization because Java serialization is very slow. It is highly insecure. And it cannot deal with complex object structure. So this is the reason why we developed Eclipse Serializer, which is a serialization we have written from scratch. It can deal with highly complex object structure. The depth of your object graph is not limited. You do not have to implement serializable, so it's very convenient to use. And it's very fast and it's highly secure. So it cannot be you cannot inject malicious code through deserialization attacks like with the Java serialization. So Eclipse serializer is very secure. And Eclipse serializer is the core of EclipseStore. So you change your object in object graph, you call a store method, store your object. EclipseStore generates a binary representation of your object and stores the binary on your hard disk drive, for instance, or wherever you can store binaries. So you can choose your storage target freely. So by the way, you can find, of course, the code on GitHub. We talk about an Eclipse project, so we have used the Eclipse public license. So it's not only open source, you can also use it for commercial software. So this is allowed by the Eclipse public license. And please feel free to contribute. So register as a contributor, and you don't have to write code. You can also support us by reporting bugs, for instance, or maybe add some examples or write some documentation. You're invited to support the EclipseStore team, or please star us on GitHub. This would be very important. So if you star us, you will pay us. This would be incredible and a great motivation for our open source team. To use EclipseStore is very simple. It's just a Maven dependency. And then through runtime, you need an EclipseStore instance. And you need a root object and a storage target. And then all objects that are reachable from this root object can be stored by EclipseStore. This is how it works from the fundamental principle. So this is just an animation of course. Christian will show the code later. So let's add an object to our root object, and then let's store it, and then let's see what happens. So it's just a store method, store a custom object, for instance. So it generates a binary representation of the object and stores the binary data in our storage target. Storage target can be an SSD, or can be a blob store like AWS S3, for instance. So whatever you can use for storing binary data. Let's add some more objects and store the objects, and look what happens. Another binary data is created, and the binary is stored appended to the file storage. And now every single time we add new objects, we will create new objects, new binary files, and it will be stored appended to the file storage. So whatever you do, you will create a new binary in your storage target, and it will be stored appended. Each action appends a new binary data into your storage target. What happens if you start an EclipseStore app? You start the EclipseStore app, your Java application or your microservice, then the root object will be generated, and then the engine will load the whole object graph. Now I have to be careful. It will load the whole object graph into the memory, but not the objects. Only the object IDs will be loaded into the memory. So to be able to create the object graph in memory, so it's a kind of indexed object graph in memory, but without objects, without any data. So this will be very fast, and you can even load 500 an object graph which is managing 500 gigabyte data, you can load the object graph in memory in milliseconds or seconds, because no data is loaded initially. As a developer, you can define whether you want to preload also data in memory or not. So you can define you want to load maybe 10 megabyte data. You want to preload 10 megabyte, then you can preload data also. If not, then your object references will only be loaded when you touch the object by calling a get method. This is how it works. And Christian will also introduce you to the code, how it works. And it's very simple. So to load subgraphs into the memory. So now this is very important. We talk about in-memory computing, which means memory is great. And memory is expensive, so you don't have to load the whole data base into the memory. You can deal with small memory sizes. This is basically possible. The more memory you have, the better it is, of course. Because the more memory you have, you can preload more data in the memory, and then you will save I/O operations. I/O operations are still the lowest part of an EclipseStore application. Keep this in mind. This is physics, we cannot avoid it. So I/O operations are always slow. But this is also maybe a very important information for you guys. If you have I/O operations, I/O operations for EclipseStore will be way faster than I/O operations with a traditional database, because you access directly a SSD drive, and we read and write data seamlessly on a SSD drive, and this is incredible fast compared to let's say storing mass data on with a relational database. So we'll have many times better performance also on your I/O operations. All right. As I mentioned, searching, filtering, you can use JavaStream's API for, and this will be incredible fast. One of the most asked questions is, but what is if my classes change? So what about schema migration? Schema migration with traditional databases is very challenging. With EclipseStore, schema migration is very convenient. So we have a concept, it's called LegacyTypeMapping. So, and the engine will always compare your objects, so the loaded objects with your classes. And if there are differences, the engine will care automatically to solve the issue. So these simple cases can be solved automatically, like you add a field, you remove a field, rename a field, you change a primitive type or something like that. It can be solved by the engine itself. And for more complex cases, you can define a legacy type mapping. With the legacy type mapping, you will define a new version of your object. You store your object again, and then it gets again stored appended to the file storage. This is very important now. If you change an object and you store it, then we will never override data in the file storage. In relational databases, we override the records, but with EclipseStore, we never override data. We always store it appended to the file storage. So if you change your classes, and you generate a new version of your object in the storage, you will have multiple different versions of your object in the file storage. So the latest version and older versions. So now we have a kind of garbage collector that can clean up your file storage and remove the older legacy objects from your file storage constantly behind the scenes. So this file storage garbage collector also works like magic, a little bit similar to the garbage collector of the JVM. So it removes the old object from your storage and cleans up your file storage constantly. All right, so EclipseStore comes with many features because the last 10 years we have solved almost any issue we had with this concept. So Eclipse Serializer is the core. We have an implementation for the JVM. We have an implementation also for Android, so you can use it on Android as well. We have this file storage garbage collector, a LegacyTypeMapping concept, as I mentioned. We have a file system abstraction, which means your storage target can be everywhere. Can store your data on Kubernetes, on mounted volumes. You can store it on local SSD drive, in a blob store, wherever you like. And you can also store your objects in multiple storage targets. So for creating backups or something like that, this will be possible. We have even database connectors, and they enable you to store your binaries even in a traditional database. This is basically possible. We have a REST interface that enables you access to your binary data, and you can also use our user interface to browse through the storage data. So it's an open system. You can get access to your data on a file storage, browse through the data, and but keep in mind, this is internal stuff. This is data written or stored by the engine, and this is not for changing your data directly on disk. This would be you would destroy your database. This is the same like you would change the binary data of your Oracle database on disk. So you would never do that. You always have to go through the application. And in terms of a database server, the application is the database management system. With EclipseStore, there is no more database management system. So now your application becomes the database management system. So which means if you want to change data, you have to go through your application, through your Java application or microservice. And this is also how you get access to an EclipseStore database. It's always through interfaces. So you can let have third-party applications get access to your EclipseStore application by using REST or GraphQL. So it's pretty much the same as database systems, but keep in mind, a database server is an application plus storage, and there is a third component. It's your application, your Java application. With EclipseStore, there are only two components left: your Java application and storage. So there is no more database management system anymore. Your Java business logic will cover everything, and you can do everything with Java. We also have Converter. You can import data, and you can also export data from an EclipseStore application via CSV export at any time. And this complete package is EclipseStore. So you get everything, every single feature with EclipseStore as open source. I hope I'm already in time. With Eclipse Data Grid now, you get way more features. With Eclipse Data Grid, you are now able to run not only single JVM applications or microservices. You can now also run distributed EclipseStore apps and scale your EclipseStore application through multiple JVMs in a cluster. So EclipseStore is the cluster environment. And Eclipse Data Grid. And Eclipse Data Grid provides you everything you need to distribute your application or your service. It's very convenient. So you just have to build your app for as a single JVM, as a single node application, like a monolithic application. And you don't have to care for whether you want to distribute your application at the beginning. And then later on, you can just change your storage manager, deploy your app in an Eclipse Data Grid, and it will distribute your application or your service through multiple instances. And then Eclipse Data Grid will replicate your Java object graph through multiple JVMs, through many JVM machines and cluster nodes. And so you can scale your app or your microservice horizontally. And Eclipse Data Grid feels like a platform, like in terms of the deployment, it feels like AWS Lambda, where you can very easily deploy your jar, but as a result, you will get a distributed, highly scalable system, and you don't have to care for that. You can configure how it should scale. You can configure how many nodes you want to start. You can configure the behavior of your cluster nodes. So when the infrastructure should scale out, and when the infrastructure should scale in, when the load goes down, everything is configurable very easily. So inside the Eclipse Data Grid, the architecture is exactly the same. Eclipse serializers used EclipseStore as a storage engine, and OpenTree9 here is only an example. Of course, you can choose your JVM freely, whatever JVM you want to use. And then you can choose your storage target. And Eclipse Data Grid will distribute your EclipseStore app. So you get a lot of features added to the great Java native features. So as I mentioned, it's great to use the performance of the JVM. It's incredible. So many people cannot believe that it's really, you talk about microseconds. Come on, this can't be true. But this is the performance of our programming language. It's the performance of the JVM. This has nothing to do with EclipseStore. Java Streams API for searching and filtering. Okay, the problem here is I can only search and filter with Java Streams API if my data is in memory. So I have to load the whole data in memory when I want to search it. No, and it's because of, now you get a lot of more features. You get the storage engine, EclipseStore. Then we provide indexing. Get an indexing concept. It's very similar to the indexing concept of the traditional databases. So with this indexing, you can search and filter billions of objects in milliseconds. So it's very powerful and easy to use. You get also a feature, it's called GigaMap. So it's very convenient feature. It cares for lazy loading automatically. So this is super convenient stuff. So Christian will introduce you to GigaMap also. Everything happens on your object graph. So Java developers have concerns about concurrency handling. So with Java, you have multiple concepts for handling your concurrency on the object graph. But to simplify this, we have now also introduced a locking API. And so this is also super easy to use and as easy to use as writing a database transaction. So this is very comparable. And the cool thing is EclipseStore is transaction safe. So it provides you ACID compliant transactions. So each store operation is an atomic all or nothing operation and transaction safe. We have a Lucene integration for full text search. So you don't have to care for that. It's convenient to use. Object graph replication and now the cluster solution. And the whole package, everything is open source and everything is provided under Eclipse public license. There is no single feature that it's missing or no single commercial feature. Everything is open source. Again, here you can choose your storage target freely. You can choose a normal hard disk drive, of course, a way more performant SSD drive. And when you store mass data, for instance, gigabytes of data on your SSD drive, it's very fast by using EclipseStore. It's almost the performance of your hard disk drive. So if you need best possible performance, use a SSD drive. If you want to use a fully managed solution, use an object storage like S3, blob store. You can use any blob storage in any cloud provider. So, and now with this possibilities now, we can maybe simplify our enterprise application infrastructure tremendously. So remember this picture. We can now reduce the architecture, and your architecture can look like this. Because of now we can use Eclipse Data Grid as a distributed cache, as a kind of cache, but not only cache, way more. So it's now recommended to take the complexity out of your database. So if you have a lot of stored procedures, PLSQL code, you have slow queries and hard maintainable code in the database, maybe your database license fees are skyrocketing. So relieve your database from all of this. Push the whole complexity into a Java layer. Run it between your application and your database and run it as an in-memory data processing system. By using core Java stuff, you you're not limited to a key value store. You can use the native Java object model, complex object graph, any Java types, no mappings behind the scenes, no data conversion, no more JSON conversion, core Java stuff. And you can store it persistently, ACID compliant on disk. You can still keep your database system, relieve your database system from all the complexity, reduce infrastructure costs for your database, license fees. And if you have trust to our storage solution, you can even skip the database and then your architecture will look like this. Then you will save a lot of infrastructure costs because in comparison to a database server in the cloud, storage is very cheap. You will save more than 90% data storage costs if you move from a database as a service like PostgreSQL, MariaDB to a blob store like S3 or just SSD drive. 90% cost savings or even more. This is, you can use your the calculator of your cloud provider and check this out and prove it. It's incredible. So, and then you have the choice whether keeping your database system as a transactional system and run Eclipse Data Grid as a kind of in-memory or caching layer, in-memory data processing layer, or even skip the database and use EclipseStore as a primary storage target. You should discuss this with your database team before you make a decision. All right. So in how the Eclipse Data Grid cluster works, this is a different topic. To summarize this, EclipseStore is an open source project. It uses Eclipse Serializer, and with Eclipse Data Grid, you get the whole cluster infrastructure. Everything is free of charge. Everything is open source and under EPL license. It is as an Eclipse project. We have regulations for our build process within the Eclipse Foundation. But with MicroStream, we provide even more security checks. We have enterprise builds and enterprise test suite, so you can also get the enterprise support from MicroStream. If you need customization, we can support you. But of course, start with open source. Open source is everything you need. So you can use EclipseStore for storing any Java object graph whenever you need it, for maybe using as a cheap persistence for your microservices. If you want best possible performance for searching and filtering, if you need a very lightweight storage without any object relational mapping framework or database system, then EclipseStore is absolutely great and lightweight and convenient to use. And now Christian will jump into the code and show how you get started coding with EclipseStore. Thank you so much. Please, yeah, this is from JavaPro last week, 2 weeks ago. So if you have any questions, please use the chat. I try to answer your technical questions, and Christian also will looking forward to your questions, because we love questions. And keep in mind, please start us on GitHub. Thank you so much. Have a great evening with Christian. Thank you.
Thank you, Marcus. So let me prepare my screen again a little bit. So now you should be able to see my IDE there, right? So just let me know if something is wrong with the screen sharing thing. So for you, yeah, to prepare stuff for maybe code along with me in further projects, you need the basic setup. Any IDE of your choice, a GitHub account, because I want to share this with you and all the projects. And then you need a little bit of knowledge of how to use Micronaut, but I will give you all the information you need, how to start a project like this and so on. Yeah, and that's all you need to code along with me. Yeah, let's jump. Before we go to all that fancy clustering stuff, we need to start at the lowest stage of the framework itself to give you an idea how it works and how to handle this. So, and therefore I prepared a very basic example. It's also the name basic example. There is only one main class, or the main method in it. And within that main method, everything is in that shows you how to basically use EclipseStore. Before we jump in, I like to share you the dependencies. That is the first thing we need. So let's jump into the POM XML. And by the way, just lean back and look, it's just for you. We will start the project together at the next project. So These are the two most important dependencies. Normally, this one is okay, so it provides all you need. But if you need to do further configuration or set some other settings, then you need the second dependencies. The latest version now is 3.0.1. So that means you need storage embedded and storage embedded configuration. These are the two most important dependencies. And there are many more. Let me just show you this within our documentation. Whatever you need. So let's say, for example, if you need the GigaMap, for example, you will find different modules and other stuff for the framework within our documentation, and that provides you all the information how to import it. Okay, so let's get into it. So let's jump back to my main class here. So, but before we're talking about the main class, we have to talk about the domain objects. There are two important domain objects I created here. One is a class named My Company, and My Company is kind of like a root entry point to our object graph. So this is the top layer of the object graph, and it could be a synthetical object like, yeah, let's call it root or whatever, or data root. But it could also be a company or a business object like users or whatever. It's totally on you to create your own root entry point to the object graph. And that My Company object has a list, a normal, straightforward array list of customers in it, and some get and set methods, whatever. So really straightforward, no annotations needed, just pure Java beats. So then let's jump into my customer class. That's the customer. It consists of a name, male, first name, and a local date, birth date. Normally every Java object type is supported by EclipseStore. There are some object types which are not supported, around 4 or 5. Really special Java objects. You will find these objects within the documentation, but all the other objects are supported. You should only be a little bit careful with third-party objects, because they could change during the time externally, and then maybe you have to refactor your storage. So they will work basically, but be careful of using third-party objects here. Okay, so as I said, nothing special here. We have the customer here, some fields, default constructor, and some get and set method, and that's it. So nothing more within that project. Yeah, but by the way, you could use records, of course. No worry with records. Let's jump back into the main class. So we need a one instance of my company here. So come on. So here, so I need one instance of my company, and then we need our first instance of our embedded storage manager. And this is kind of like the database management system. So the embedded storage manager manages everything in the background. So we need one instance per application, or you could also have multiple instances of a storage manager. That's totally up to you. And this is, by the way, the easiest way to initialize it. We need only two information to start. It's the company instance here, and it's the path where you want to store the data. And in my example here, I'd like to store the data directly somewhere on the hard disk, which is called data. We will see this later, where the folder is created then. People always ask me, what is the preferred storage layer that we want to use? In my opinion, and in all the projects we are using EclipseStore, we are using maybe persistent volumes or the basic hard disk for storing data, because it's the fastest storage you can get. In other projects, we also use an S3 bucket, for example, that is also working great, because remember, it's an in-memory database. So most of the data stays in memory, and only the lazy loaded stuff goes through the remote connection. So the in-memory stuff will be loaded fast anyway, no matter what the basic where the basic storage is. But yeah, in my opinion, it's best practice to use your hard disk because it's quite close to the application, or a persistent volume, whatever you can get within Kubernetes, for example. Okay, so we initialized our storage manager, and of course we need 2 additional objects or instances of a customer. So I created 2 of them, customer 1, customer 2, with some example data in it. And I have to add these customers to that customer collection, which is part of my company, right? So this is normal Java behavior, I have to say. Whenever you want to add something, you have to add it to your collection. And now you will see the first contact point to how to store data in EclipseStore. So we use our storage manager here, and we use the store method. And this is the point where the magic happens. So at that moment, the embedded storage manager takes over the control and stores the object directly to the hard disk. And the rule is here, you always have to store the object which has changed. So that's the easiest explanation, I would say. So that means of course we created 2 objects, right? But at the end, within the storage, we added these 2 objects to a collection. And that means we changed the collection. So that means also the collection itself is the reference holder of these 2 customers. And that's why we have to store the collection. And that is also the reason why I added here mycompany.getCustomers to store these 2 elements here. Okay, what else should we do? So we need to print out the added companies, just some output here to find it. And last but not least, at the end of the program, we try to shut down, or we want to shut down the storage itself because it's not needed anymore. And that's it. Yeah, let's give it a try. So let's start this application. So you should see the initialization of the storage down here in the console. Somewhere there should be my output here. You see that's okay. Here you see the system print line of the 2 objects down here. And more important, we see that data folder here, which is created right after initialization of the storage. So, and when we have a look at this, there are 2 files, or 1 file and 1 folder in it. And this is an example of a very basic EclipseStore storage. It consists of a persistence type dictionary. So it's the name says it's a dictionary that contains every used Java object type in the storage, and the channel itself contains the data itself. And you might ask, why is it channel 0? Do we have multiple channel files? Yeah, you could have multiple ones, but this is a topic for later. Okay, so this channel folder contains the data, and inside that channel folder, there is a channel 01 dot and a transaction file, which is only for internal purposes. So there was a question before during Marcus's presentation, how the storage works in the background. So it's an appending storage. That means whenever you change something, no matter if you update something or you add something, you always add the touched object or the changed object again and again to append to the storage. And that means the storage grows and grows more and more. But there is kind of like a housekeeping working in the background. And it closes, or it reduces the amount of the storage in the background. You don't have to take care about this. So, but it's an appending binary file storage. Okay, so now we started it once, right? So that means these two objects should be available after a restart. So let's give it a try. So we do not need this code anymore, right? So because these two objects should be already in the storage. So we just need our system.println, and let's start it again. So we will see. So here we are. That was the second run of the tool, and we see here is the output again, and we see the two stored elements that are in my storage. And that's it. That is how the basics of EclipseStore is working. So it's easy. I would say it's the easiest storage as it can be. Let me just have a short look to your questions here. I always see your questions on the left monitor. So, when you are storing the customers like this, it means that the change will involve only storing the customers rather than the whole My Company graph, correct? Yeah, it is like this. So when we store or when we add something, the collection will be stored, of course, but not with all the data, only with the references, or only with the references to the objects. And but the collection itself has to be stored again and again, and but without data, of course. The collection only contains the references. I would like to filter a collection. Does it mean every object needs to be loaded? Yes, that comes a little bit later. We will talk about this. When you want to filter it, you're using the JavaStreams API, and you need to load the data. But therefore, we have different solutions that we talk about a little bit later. Okay, so okay, let's move on. So, and I mean, it's time to start with a hands-on example, and therefore, let me jump to a different IntelliJ project, and let's start with the step-by-step. Here we are. Okay, so let me just move this window to a different. Okay, that looks good. So let me first share the repository with you. So I have to copy this. So this is the project we want to start with. So feel free to check it out to your IDE. And there are multiple branches in it. And for me, I'd like to start with the branch. So let me just move to a different one. Yeah, I'm start with the first branch, beginning. So that's the starting point for me. And it's the same for you. If you want to code along with me, check it out, move to that branch beginning. And if you just want to lean back and have a look on the code, which is inside the project, feel free to move directly to the controller, create books done, then it's also okay. The project itself, it's a Micronaut project that is mostly used in combination with EclipseStore as, we call it data provider. So microservice data providers. This is so, a little bit the key thing of EclipseStore. So it's also in kind of like writing your own database, right? So it's you could have multiple different data providers for each topic. Let's call it topic of your database itself. It could also be used kind of like of sharding your database a little bit within microservices. So that's why we start. I want to start with a Micronaut application, and let's just move on directly. So let me prepare my right screen a little bit. I always need a little bit of help to see what are the next steps that we need to do. Okay, so first we need to check. So yeah, if I'm too fast, just give me a short sign that I should explain something more in detail. But yeah, I will try to do my best to go as efficient as possible. The first thing that we need to check is if the dependencies are available. So, and I will do the same. So let me just check if there are any dependencies available, and no, there are not. So that means we have to add these dependencies. And to make it a little bit easier for you, let me just share these dependencies also with you. Just a second. Is it the right project? It is. Okay, here we are. So as I already explained, these are the two dependencies which are necessary to handle EclipseStore, and these two dependencies will be copied to the POM XML, and we need to do an import. And yeah, as I said, it's 3.0.1 is the latest version. We need the storage embedded and the storage embedded configuration. And with these two dependencies, we are good to go. So that means we could close the POM XML. That's all we need to have at this point. And that brings me to the next step. Let's create one class, and let's call it a DB class. So let's start a new Java class. Let's call it DB, and let's do it like this. And some of you might say, oh, this is not the best way how to code within Micronaut and so on. You are totally right. So for now, I will do horrible things within that Micronaut application, because I will not use any dependency injection or stuff like this. I will create static stuff in that application. It's not the right way doing this, but I want to keep this example as easy as possible and more understandable for you. And that's why I don't use all that fancy dependency injection stuff, because yeah, it's working. Also, there are projects I will share with you where everything is fine and I use this injection stuff, but not on this example. Okay, so let's create that DB class as with some static content that is needed So first, we need our embedded storage manager. So let's say public static embedded storage manager. And let's call it storage manager. Here we are. Next step is we need our root entrance point. So that means that it was my company in the last project, and now we use a synthetical one. So let's create another class which is called data root. For those of you who might ask, what could I have multiple data roots? Is it possible? No, it's not. You could have multiple instances of a storage manager, and this storage manager itself could has the data or has different data. That's possible. But it's also possible to have multiple collections, of course. And then the data root itself is at the one side, it's the entrance point to the graph, but there are many other objects within that data root, and this splits up your data. So it's most of the time it's not necessary to have multiple root objects. Okay, so data root. We need to have one. We need some content here later, but it's okay to leave it as it is for now. Just an empty class. Let's jump back to the DB class. So that means we initialized our embedded storage manager, and on the second step, we want to initialize our data root object, our root object. So let's say public, let's do it final static data root. Let's call it data root, and let's directly initialize that data root object. And now let's create a static block. Some of the Micronaut developers would cry if they see what I'm doing here. Static block. So this is the point where I initialize that storage manager. Storage manager equals, and then I'm using the embedded storage configuration. This is where our second dependencies comes into play. So there is the embedded storage configuration dot, and then there is a builder pattern available. And this is used to do all the fancy configuration stuff with EclipseStore. So it provides different set methods. So for example, set storage directory. Let's call it data the same way that we had it before. Then, and we could do some more. And one of this, maybe an interesting thing, is set channel count, for example. And do you remember that short hint that I gave you with the different channels? There is a possibility to create multiple channels for multi-threaded writing down data directly to your hard disk. In some cases, it makes sense to have multiple threads, especially when you deal with bigger data or with bigger files like document or so on. Then it could make sense to write down data in a multi-threaded way. And for each thread, we need one channel because of the write lock situation. And that means, and channel count must be always a power of 2. So that means 1, 2, 4, 8, 16, and so on. And but it's not that complicated, because in my whole lifetime using EclipseStore, I'm just using something like 1, 2, 4. That is the biggest channel count I've ever used, to be honest. And just try it out, because more channels will lead to a more segmentation of or fragmentation of data, and that could harm the performance of reading stuff. So something in between 1 to 4, it's a sweet spot, I have to say. Let's say channel, but no worries, you will be able to change this later then. So maybe you decided to use one channel at the beginning. You could easily change it to 2 or 4, or you could even grow. Okay, so for now we do not need it, but yeah, let's do this just for fun. Let's say set channel count. Let's say 2. That's totally okay. Next step is to create an embedded storage foundation. This is always necessary. Creating a foundation which provides all the different information, and based on that foundation, we will create our embedded storage manager. And that storage manager needs to know the root object, right? So we need to hand over data root, and last but not least, the most important step, we need to call the start method. Otherwise, the storage manager will not start. This is quite important here. And believe me, I forgot this several times in the past, and it's interesting to find the error why data is not stored. I do not understand what happened in my project. And then after half an hour of searching, I recognized that I missed the start. Yeah, exactly. So there is one question from Anton. Does this also start the background housekeeping process you mentioned before? Exactly. This is where everything starts up and the process starts. And this is, by the way, also the moment where all the data is created right after the beginning. So right after, the start, files are created and so on. Okay, so that's it for the DB class. So nothing more to do here. Let's jump into my data root. So now there is a lot of normal Java stuff going on. So say data root. But for data root, we need some domain objects, right? And let's create some of, let's say, okay, let's create a package and call that package domain. Oh. And we want to deal with two different Java classes or two domain objects. One is a book object, and another one, let's call it author. So at this point, when book and author is created, we could directly go back or jump back into my data root class, because this is the moment where I can create my first collection. So let's say private final list of books. So let's initialize it with equals new array list of book. And let's import this get books. That's all we need within the domain, within the data root object. And that list here could be a lot of other things. It could be a set, it could be an hash map, it could be a giga map, whatever you want, whatever collection you want to use here. You could also use some other, let's say some, how is it called? All the different concurrent collection solution that Java provides. Whatever collection you want to use, feel free to use here the best collection that fits best to your data structure. That's always a big thing here. But for now and for our example, list is totally okay. So a list of books. And now let's move to the book object itself. So we need some more detailed informations regarding to our book. So the first thing I want to set is a private final string, which is called ISBN. So that's for sure one of the most important informations on a book itself. And this is also the point where people ask, what about a primary key, a foreign key, which is normally available within a normal relational database, for example, to identify it. It's not necessary anymore to have a synthetical primary key because the storage EclipseStore is based on the reference model of Java. So we do not need any connections anymore in between objects because the reference model does this for us. But we need some identifiers, of course. And to identify one specific book, the ISBN is totally okay because it's a unique number that identifies a book itself. And if there is not a special, let's do this. Then you could create something like what we normally do is private string UUID. And then we create a UUID like this. This works also great to create a unique identifier within EclipseStore. One question regarding Lombok, feel free to use it. It will also work with EclipseStore. Okay, so this could be good, but in our case, ISBN is totally okay, or I'm okay with the ISBN. So we need another name. So let's say private string name or title. That's on you. And of course, we need an author. So, oh, sorry, that's not a string. It's an author. So, and that brings me to the point where people always ask about querying and how querying is used and what the problem is on querying data and loading collections for doing Java streams. And this is one situation where you see that the data structure is a little bit different to a relational object, to a relational model, because when we're searching for a specific author, we do not have to go through a list of authors to find a specific one. Let's say the book itself has an ID of an author in it. And then I have to go to the author table and have to find the ID out of thousands of different authors. It's not the case here anymore. That is also the reason why the amount of queries which is needed to handling the data with an application is quite lower than with any relational solution, because we always operating on the object itself, and the additional information is always right in the object. And that's the situation where, so let's say searching for something is okay when we're talking about reporting and some calculation stuff or whatever, but the normal way we operating on our object graph, and then there is no big querying is not necessary anymore. And this is, by the way, there is another question: do we need a table which provides all the authors anymore? Maybe, maybe not. It depends on your business needs, but I will come to this a little bit later. Okay, so we need to create some other things here. Let's generate get and set methods. Let's do so, and I also want to have a constructor here, generate, and let's do it this way. That's all for my book class, 3 fields and a constructor and get set methods. No annotations, as I already mentioned. One question from your side regarding the identifier. You mentioned you could use your UID. What if you need to perform range queries of all the books added in order? Is there a concept like auto increment? Perform range queries. What do you mean with range queries, or should you manage that? So yeah, basically you could do this by yourself. So remember the point where I told you that this is a list, right? So let's imagine we have millions of books, for example. Then it could make sense to have a structure like this: private, yeah, let's say final hash map, and then we say, okay, the first oh, come on, so this one, and let's say string and list of book. So you get the idea. So when you're using things like this, you will be able to create your own index, maybe based on that string. Let's say the very first digits or the very first 4 digits of an ISBN, for example. It's totally based on your object graph, and you could do whatever you want in your structure. Choose the best thing for your business needs. Yeah, use whatever it is provided by Java. So that's what I can say. And then it is even better when we're talking about that question: do we need to load everything when we want to search within a lazy structure, for example? Because this list here is always in memory. So, but this list could also be something like with lazy, but we will come to this a little bit later. But I think you get the idea. So it's up to you choosing the collection which fits best to your business needs. Okay, so book is finalized. So let's move on to the author. It's also an easy thing. So, and for now, I just copy paste to accelerate that a little bit. So we have in it mail, first name, last name. In my case, the mail is a good identifier of an author. It's just for as an example, then it's totally fine having that this way. Okay, author, book, both domain objects are available. Data root, we do not need a hash map anymore. Okay, so let me check. So we have our DB class in it. So to initialize the storage manager, we have the data root, which is the entrance point. Then we have two domain objects. So next step would be how to access the data. So now the micronode aspect comes into play. We need one controller, right? So to access the data. So, and for that, let's create a new folder or a new package, and let's call it controller. And now let's create one Java class, and let's call this book controller. Oh, come on. So here we are. Okay, so now a little bit of micronode stuff comes into play. The first thing we need to annotate the controller here. And let's use controller, and let's give this controller a URL. So let's say /books. So that means whenever we later call localhost.8080/books, we are in that controller here. And then we need one entry point or one interface. And I also copy pasted it directly. So we need a get here, a create method. So because we want to create data. So let me just import all that stuff. So using author, import, book, import, and also DB. Oh, come on, what is that import class? This one. Yeah, which is called data root. That's okay. Import. No worries. I will copy paste this to the chat so that to make it as much easier for you as it can be. So this is the code. Just copy paste it to your controller class. And let's go through that code. Let's talk a little bit what happens here. So there are two authors created. Nothing special, just pure Java, a few books, only 4. Then we need to add these 4 books to our books collection here. So we move to DB. That's the reason why I use the static initialization of the DB class. Let's say .dataroot.get books, and then I have to add all these created books here. And as always, I need to store the element which has changed within our data, and it is the get books collection. And that's also the reason why I hand over get books. I need to return something, so that means book successfully created. Okay, let's add another one because we need to see the data. And this is a quite small interface. Let's use a get one. By the way, using get is also not the best practice, doing this of creating stuff, but I want to keep it as simple as possible, and that gives you the possibility to call this interface within your browser to see. Otherwise, when I use a post, we need something like Postman or whatever. So public, we want to return a list of books, of course, and let's call it get books. And IntelliJ automatically adds the necessary part here. So let's say return db.dataroot.getBooks. That is all we need. So this is, by the way, one example how to provide or how to get data back. So you don't have to take care about loading it. You're just operating on your object graph. That's all you need. Everything is handled in the background by EclipseStore. Okay, so we initialized our database. We have our root object, book and author, that's our domain objects, and we created a controller. And that's it. Yeah, that's our example. So let's try to start. I need to stop. You see that there is already a data here. So now we are good to go. Okay, you should see the starting prompt here in the console with Micronaut, and you see the server is up and running. There is one thing I need to mention. You need to enable your annotation processing to get it run. But this is, I would say, it's a default setup. But this is an important hint. And now this data provider application should be available on localhost 8080/books. Right? So you see that this is the return value when I call localhost 8080/books, and I'm getting an empty result. Oh, come on. Oh, what's going on here? So now let's do this way. So now that's an empty result because it's nothing in it. And let's call the create method /create. Book successfully created. And when we now call books again, we should see our 4 created books within that example. Okay, so we could also call this books/create methods 100 times. So let's do it this way. Let's see what happened. Now we have many books in our application. So let's restart that application to prove if everything is stored like it should be. So I stop the application. I start the application again. Server is up and running. Let's directly jump to my browser and let's call the books method again. You see EclipseStore is initialized again down here. And you see, here's the data. Okay, let me jump into your questions. Okay, for instance, fetch the first 1000 books in the order they were added to EclipseStore. That's an easy task, right? So just use the Streams API to create a pageable thing to just, yeah, that is stuff that is provided by the Streams API. Yeah, created at could be the case, of course. Yeah, just to get an idea what you mean. So this is all what the Streams API provides. But I will come to that a little bit later when we're talking about the CRUD functionality. Okay, some more questions from your side regarding that example? Does it run on your side? Did you try it out? So as I said, feel free to check out directly the branch number 6, I guess, controller create books done. That should do the trick. You could directly start it right away and create books and store books and load it and so on. That should work. And now another question comes into my mind that is often asked. What about, is there a tool that allows us to have a look what happened inside the database? Yes, there is. There is a slightly small tool that we provide. It's kind of like a small REST interface that it's automatically created in the background. But I will show you this at the end of today. But the tool is your own application, right? You could create as much interfaces as you want. So you could use your own REST interfaces to see what's going on in a database, to have a look on the data. So this is how we do it within our projects. We do not need a database management tool because we're creating our own database provider. And we see the structure right in the object graph here in the Java code. And at the beginning, to be honest, at the beginning, it was also a little bit confusing for me to not having a tool to see what's going on. But so after working a few weeks with EclipseStore, it feels totally nature using these REST endpoints to see what's going on in the database. Java flight recorder events, that's a good question. I'm not really sure, but I would say yes, because there is an interface to the Java metric standard, and that could also help. So we will have a closer look with Visual VM later on, but for flight recorder, maybe I have to ask some of my developers. I could not answer this properly, but I would say yes. So what is the largest data store you know? Based on a single data provider, I would say around 100 or 120 gigabytes is the largest one I remember on a single instance. Yeah. But it always depends on how much data is lazily handled, and as I remember right, this application was managed by a 24 gigabytes RAM machine or container. But it always depends on the amount of users, because the more concurrent user you have, the more data will stay in memory, and all that stuff yeah, you need to consider. High frequency trading platforms. Good question. Not from my side. So there is maybe there are. It's always a little bit a problem because of its open source. Everyone can use it, and it is on the market for years now. Maybe there are, but not that I know. Maybe my colleagues have more information regarding this, but normally so maybe I have to say this. Normally I bring a performance demo with me, but which shows quite impressive how fast EclipseStore is compared to a PostgreSQL database. But unfortunately, I changed my operating system to Windows 11, and since that change, I'm not able to start my Docker desktop or to start the project in Docker desktop anymore, because the C advisor is not running anymore, and that leads to no data for CPU in an example, but it's quite impressive. So just to give you an idea, when we have reading stuff ongoing, then we have on PostgreSQL, we have around 2,000 reads. Let's say 2,000 reads per second or per minute? No, per second. Or per minute? Sorry, I don't can't remember. Need to start the example, but it's yeah, it's 2,000 compared to 56,000 on EclipseStore. It's so much faster than accessing a database. That's really insane. Give it a try by yourself. Just add data and try to search within. It's insanely fast. But it always depends on how much RAM do you have, and the amount of concurrent users, and some other things like how the concurrency handling is working in the background. And there are many different factors. But good news is, with EclipseStore, you finally are able to design an application or a data structure that is specially made for your use case and for your data. You do not have to align to a relational database model that is sometimes really weird. Yeah. Give it a try. And as soon as I can bring back my performance demo back again, so I try to share it. Yeah, good question. Could you explain why you have called DB Storage Manager store get books? So you mean, oh, that's a different, but it doesn't matter. So let's jump into this part of the application. That's the next project for the next topic, but that's okay to clarify this. But before I jump into this, there is one situation I want to clarify on the other system here. We talked about this situation. There is an author within the books, right? So this is what we talked about, and we created it this way. And the question is, do we need a collection of authors somewhere? So why we do not have a collection of authors within the data root, for example? What do you think? Is it necessary or not, having a list of authors? Well, it is always the same. It depends on your business needs. Let's imagine you sell the last book of a specific author, and you remove it from that book list. Then the author is gone, right? So when you now want to fill a combo box, for example, or a select UI thing, yeah, then you need a list of authors, right? So it's all about your needs. So if you need to have a list of authors, feel free to have it here. So, but the question now is, now we have a list of authors here, and in addition, we have an author object here. Does that mean it doubles the amount of RAM that we have? What do you think? No, it does not, because each author is just a reference to one central existing object. So it doesn't matter if we have one author reference here to, let's say, X and Y author, and the same reference is handled here in the data root. It consumes just once data or RAM, as I said, because it's except the reference memory consumption, because reference there are multiple ones. Okay, so it depends on your business needs. So let's jump back to the question. So let me stop this. It's no longer needed, that example. Let's jump into the next project, and let me just share the URL of the project itself, so that enables you to check out one example of CRUD functionality. So create, read, update, and delete. And some of these cases we already talked about, and that brings me to your question back. How about why do we need to store the collection of books? You see here it's the same situation. We add some books to that collection here, get books, and then we need to store. The reason why it is, in the background, we need to register these created books, or we need to register these objects to that collection, because the collection itself holds the references to these entries, right? So that means the collection itself has changed because it gets the references to these books, book objects. And that's why we have to store the collection itself. I know that you are used to use the object which has created to store it on a save and then add book to it. That is how a relational database works. In EclipseStore, it's a little bit different. You always have to store the object which has changed, I would say. That's the easiest explanation. Is that okay? Okay, so let's move on. So let's talk about these CRUD functionality. So create a single book is in a way the same like let's create multiple ones. At the end, you add that single book to a collection of multiple ones, and you have to store the collection. That's always the same. A little bit different it gets when we're talking about updating a single book, like this one here. Update a single book. In this case, we have to find a specific book, of course, and then we say, okay, book.setRelease. So to change the release date of that book. And now the situation is the same. The object which has changed is the book itself, right? Because the book object holds the reference to the local date object. And that's why we have to store book itself. So this is quite as usual, because you change something on a book object, then you have to store the book object. It's mostly different, or it feels different when we're talking about adding something to another object. Then you always have to store the receiver. Okay, so that's it. But how about searching? So, and this is always also, or mostly, a big topic, because we need to find the data, or we need to search within the data. And this is where the Streams API helps us a lot. So I would say, in my opinion, there is the Streams API covers everything that also, let's say, SQL can provide us. So there is a possibility to filter, to search. So we have a lot of different possibilities to, let's say, starts with an A, replaces, contains, lowercase, content equals, is empty, is blank. You know it, the Streams API is such a powerful API that can be used to search for everything which is needed. But there is some more possibilities later on. But this is the most important one when we dealing with EclipseStore. And in this case, and for those of you who never touched the Streams API, it is always that 3 steps. At the beginning, we need a reference to our collection. Then we're using that streams keyword, let's say, or the stream method. And based on that stream, we could start with different things. We could call, let's say, a map. That means if we want to, let's say we want to stream through maps, we want to stream through books, but at the end we need a list of authors. Then we would use the map functionality. Let's say map, and then let's call B for book. And then we could say b.getAuthor, for example. So then at the end, when we say, okay, this is not needed so far, so then this stream would return a list of authors at the end, not a list of books anymore, because that map functionality, it's the same. We could use flat map, for example. It is called like this. This is always helpful when we do not have a single reference instead of multiple authors. Let's say maybe there is a book with multiple authors in it, and we want to have a list of authors in the same way, then we would use a flat map. That and many more of that stuff. So that means the stream keyword or method provides us the possibility to filter, to map, to flat map, whatever. And at the end, so we have the filter statement here, and at the end, we need we need to say what we need to return. So we want to collect this to a list, or we want to collect this to set. There are many different possibilities to map and so on. This collects the result at the end. And this is always, these three elements are mostly the main elements of a stream, of the Stream API. There are many more possibilities, but the internet is full of examples of the Streams API. And yeah, just check it out. It's a very powerful API. Okay, so, and this API is used in this case here, just to return all or every book that starts with an A. And for that, we're using the starts with A, and that returns that book. Okay, that's all about querying, right? So later we will see some more examples when we're talking about the GigaMap and so on. There is a more advanced API, but it's okay for now regarding the Streams API. Let's move forward to clearing things. What about when we want to delete something? That is also as easy as it can be. So let's move to the collection, get books, and let's call it clear. So on the Java side, we are clearing that collection. So the collection is empty, and now we have to say, now we have to synchronize this to our storage layer, and that's why we're calling db storage manager.store and hand over the changed collection of books. Easy, right? So that's not really complicated. Update a single book. We already talked about this. We changed the book. We have to store the book. So what about, just a second, I have to move this. Okay, this is not needed anymore. Okay, so that brings me to this example here. What about updating multiple books? And this is an important topic when we, because this is in many cases that could be really, really helpful. And this is also a mistake that is made a lot when we're talking about our customers. They are asking for, EclipseStore behaves slow, what can I do? And in many cases, this is one of the reasons why it is not working as fast as expected. Okay, so let's say we want to change the price of multiple books. So in that case, we are using the method from above. So let's call for every book that starts with an A, and then we iterate through these books and adding or changing the price and setting to whatever it is, 90 cents or what, I don't know. It's not that important. Then we could say, okay, the book has changed, and now let's call db.storage-manager.store B, right? That's exactly how it could work. And you are right, this is totally working, but you should always consider this store is a blocking operation. That's important. So that means when we're calling store in that way, that will slow down my iteration drastically. And that should not be the case. So in this situation, we need a different solution. Any ideas from your side? How it can be differently? Well, we could do it like this. We could say store the root. Oh, that's an interesting solution. Exactly. So we could say, let's store the root. db dot storage manager store. Instead of get books, we're storing root. This will not work because for two reasons. The reason number one is when we're using store here in that way, then we are using as I missed the word. So we are using a lazy storing functionality. That means only the changed objects, only that direct changed object will be stored. But I will come to that a little bit later. So in that case, this will not work. But there are a workaround that brings this to work. And I have to warn this because you remember EclipseStore is working as an appending storage. Now, let's say we force EclipseStore to store the root. What will happen then? The whole root, that means the whole database, will be append to the storage. And this will lead to a huge growing storage on your hard disk. So it will work, but this will grow your hard disk. At the end, housekeeping will delete all that stuff, but this takes time, and you should be careful using such a functionality. And I would never recommend this. It could be the case in some rare situation to use this method, but I would not recommend this. Okay, that is not best practice. Store all or store all iterable? Yes, exactly. So that could be one solution. So let's say doing things like this. So now we have that list of, oh, I missed all the others. So this emitter, right? Dot. Sorry. Oh, no. We are here, filter, dot. Oh, come on. I missed the string here. Now we are talking. So collectors to unmodify, whatever, doesn't matter. So this is this. Now we have a list of books. Now that enables us to iterate through these books. And at the end, I'm able to say db.store manager store books, right? So this is one possibility, and this will work much better than all the solutions before. But there is another way, a more interesting way of doing this, because this is a lot of typing stuff and so on. So let me revert this. So let's create a storer. Let's say db dot storage manager dot create lazy storer. So, and there are two methods: a create lazy storer and a create eager storer. This one here. And these are the two different storing behaviors in the background of EclipseStore. Lazy storing stores only the given object. That means, let's say we changed something within a book. Let's say we changed the author object or we changed the title. Then we are totally fine to use that lazy storer here. That means it only stores the given object, not without the underlying sub-elements. And the opposite way is create eager storer. Eager storer stores everything below below the object. Let's say we have a book object with an author, and we changed the name of the author. That enables us to use the create eager store and then say store book. This will store the author object. But you see the risk in that situation. Eager storing stores all the underlying sub-elements. And now we are talking about an appending storage and so on. Be careful with those eager storer. These eager storer are very helpful in some situations, but mostly the lazy storer is the best choice. So let's use this lazy storer and create an object called ls for lazy storing. That ls provides me the possibility to say ls.store b. And this might be a little bit confusing to you because the wording is misleading a little bit. The store here means B is registered to store later. So it's, as I said, it's sometimes a little bit misleading, but and guess what? The command is at the end, it's ls.commit. And right at that moment, all these changes are stored to the database. And this is also the point where we're talking about some transactional behavior. That means if something goes wrong during the iteration here, that gives me the possibility to do a rollback within a try-catch or so. Yeah, it's kind of like a prepare commit for databases. Exactly. It's that normal transactional behavior. So because whenever something goes wrong here, you need to revert your changes which are already made in the RAM. So that's exactly the case. Okay, and I would say that's the most elegant way storing things, and just register the changed object and store it at the end. Regarding that rollback, there is a rollback functionality. I have to check. Give me just a second. I just want to jump into that transactional behavior, storing data, reloading. Here it is. So you will find this information directly here. So there is a reloader object that enables you to reload flat or reload deep. So that enables you to restore data if it's already changed or if something goes wrong. And for handling that situations, just use the normal try-catch error behavior of Java. And with that, you will be able to, to simulate a normal transactional behavior. Okay. Another question. Lazy eager refers to the depth of the object tree that is inspected, not the point in time later versus now. No, it's just lazy eager refers to storing all the sub-entities within an object, no matter if there has changed or not. So, but there is one different, or there is one thing which is different when you let's say no, I don't, not that important. So we will talk about this a little later. Okay, any questions regarding this? That's important to know how to store, and these are the most important capabilities of storing things. You always have to keep in mind you have to store the object which has changed. That's important, and not doing stuff like this for storing within an iteration or so. Therefore, it is more important to use the lazy storer this way with that commit behavior. Okay. If there are no further questions, I would move forward to lazy loading. So I would call it the elephant in the room. and mostly a very interesting topic. What does lazy loading means and how does it work? Okay, I prepared a small presentation to make it more understandable for you. And let's talk about why do we need to store and load data in a lazy way? What data should be stored and loaded lazily? How to use the lazy reference is also important to know. And of course, as always, some best practices from our projects and our experience regarding this. And how to release lazy data. This is also an important point. What happened with the data once it is loaded? How could we release it again? There is a lot of stuff within the documentation, but let's move on. Okay, first, it is important to know that EclipseStore is by default an in-memory database framework. So it's specially made for calculating data within memory. And this is also the reason why it is so fast. So using EclipseStore without an in-memory part, I mean, it's possible, right? So you could write in the root object, you could define a lazy reference for everything. That's totally up to you. You can do this. And then you will be able to store a 1 terabyte data blob, maybe, to EclipseStore. No problem, because it's loaded lazily. But you should always keep in mind that when the more people are working on your object graph, the more data will stay in memory anyway. So that means that's straightforward, I would say. And yeah, it's made for in-memory processing, of course. This means you will get best performance. The data must be in the RAM. But maybe another thing, when we, even if we would have everything loaded the lazy way, EclipseStore would be much faster than all the other databases because we do not have that OR mapping anymore in between data. We do not have to convert data anymore. It is stored as it is, as a reference, as a Java structure, right? So, and there is no conversion anymore. And when we have a look to all the relational databases and so on around, yeah, it depends on the situation, but when we inspect some performance issues on relational databases, then we see that OR mapping is a quite expensive task, and it's from 10% to 50% of the performance falls to the OR mapping. And this is no longer needed here. So it is possible to have everything lazily loaded, and it's faster than other things. So the point is, in some cases, it's impossible to hold all the data inside the RAM, especially when binary data comes into play. And of course, sometimes it's just unnecessary to hold all the data inside the RAM. That's an important point, because when that question comes, always. So how much data can we store? And then they ask us, is it possible to replace a 40 terabyte database with EclipseStore? Well, it could be possible. It depends on the amount of RAM, on the concurrent users, and so on. But is this really needed? So does it make sense to store 20 terabytes of binary data, let's say documents or whatever, within an in-memory storage technology? Is it really, does it make sense? Maybe. So when we're talking about providing these data in milliseconds, for example, then yes, it makes sense to have this, but most of the time it would not. And that is the first point. Why not to store binary data on an AWS S3 bucket as a normal binary blob? It's much cheaper and it's not needed anyway. And one more important thing is it does not need it to be processed by the server itself. You know, Every time when you touch a binary part of your database, it has to be processed through your application server to deliver it to the customer or to the user. And this is workload on your application server. And it doesn't make sense. Just store the data directly to AWS S3 and load it directly from there and deliver it directly from the binary storage to your customer, and you do not have to process it. So that means binary data makes not really sense in most of the thing to have it in the database. Now, another point is, how about archive data? Let's say they told us we have 40 terabytes of data in your database. The next question is, do you really need all that data all the time in scope of your application? Well, and then they say, nah, it's the data of the last 20 years and we have it in the database. So, okay, let's talk about how to archive data and how to move some no longer needed data to a more cheaper data storage and only use in-memory technology or whatever for the most important data that is needed all the time, every day for every user. And all these things needs to be calculated when we're talking about the usage of an in-memory technology. And now it is so when we look into the past, so when we're talking about data storage, always we're talking about, oh, we need a database and we store everything inside the database. But now with microservices and so on, we have the choice to say what is the most frequent data and where to store it, and what is the less frequented data. Let's store it differently on another system. Do not store everything in one place. That doesn't make sense at all. So, and this is the point where the lazy storing here comes. Sometimes you need to have the data here, but it's unnecessary to hold the data inside the RAM. Then you could also use that lazy functionality. Okay, so how lazy is working? Normally, at the beginning of a database startup, when we have, let's say, we have 100 million objects on disk, on startup, you will have 1 million objects within your RAM. So this is how it basically works, and it is loaded right during the startup. Now let's imagine that we have several points here, some lazy points here. Let's say object 1 here is a lazy object, object 4 here, and maybe these objects here. And on startup, your object graph looks like this. We only have, and maybe I have to say these 2 will also be not available. This is an error on that slide because when we load object 1, then it loads 6 and 7, and 4 stays on the hard disk because it's also lazily loaded. So, and with that mechanism, you could decide which data should stay on the hard disk, which data is needed all the time, what is the primary data of a specific object, and so on. Many different possibilities. So the question is when to use lazy loading. A recommendation: always on blobs, documents, images, always on huge collections. So remember, when we're talking about huge collections, let's say millions of objects within a collection, then we need to find a way how to paging them, handling them, lazy loaded, and so on. So we need to find a solution here. Remember that hash map I showed you with that manual index of the first 4 digits of an ISBN. Maybe this could be a situation like this, but with less frequented data. That is important, because even when we have a huge collection and you would say, okay, this data has to be available all the time, or let's say there are hundreds or even thousands of users working on that data, then this makes no sense to lazily load these data, because this data needs to be in RAM anyway. And it's the same like if you have 1,000 users on your application server, and you have to load data from your database. The data is in the cache on your application server side, and you will need to hold that data anyway. Sometimes on collections with huge amounts of sub-entities, that could be the case, but I would also prefer to set the lazy points on that sub-entities. That will also help. And basically, whenever you want, if performance isn't that important in this part of the data model, or the amount of RAM is limited. Let's have a short look how a situation could look like. So this is one example of having lazy bytes. But a better solution is this one, a hash map with a string for a description or adding some more information regarding that lazy byte here inside that enables you to stream through the key here or find or search or whatever, and then choosing the right byte here. So a document hash map, for example. We already talked about this, documents and so on. This could be one situation, a list of books, but to be fair, this is not the best way of handling this, because at that moment when we need to stream through these books, we have to load the whole list always, because streaming through needs to be loaded, and this list of books stays then in memory for the next, let's say, half an hour, for example. But this is the easiest way how to use the lazy reference here. This is a more elegant way using lazy list of books. This is exactly the example I already mentioned regarding the 4-3 digits of the ISBN or some other keys or indices. A quite good way for handling lazy elements. Index could be whatever you want. And this is an important part when we're talking about releasing data. That means there is a possibility to do this the manual way. So that means lazy image dot clear. That is the lazy element itself. And then it needs a little bit till the garbage collection comes and cleans that object. But the clear method on the lazy element here releases the lazy reference. But on the other hand, there is a second solution, which is the default ones. It's if a lazy object stays untouched for the last 30 minutes, then it will be released. Or if we're reaching a memory quota of 75%. And there is a more advanced situation, because there is that question, can you lazy load chunks of a collection? Yes, we do. There is that gigamap we already talked, and I will provide you an example in a short moment. Okay, so let's jump into a project. That is the gigamap example I talked. So lazy demo. Okay, so we start with sharing the URL. Here it is. So feel free to check it out, to try it out, to load data, whatever you want. Okay, so this is a project which is separated in different steps. And let's start with the very basic master branch. There is no data so far. And I would directly, let's have a short look to the data root. We see there is a list of persons or a list of people here. And there is one controller interface here to create multiple peoples here. So let's say, let's check this out. There is a range of 200, and you could see there is, let me just double check where it is. Resources, mockup. Yeah, there is a person JSON file, and it contains 1000 person objects, and these objects are not the smallest ones. You see there is a huge string at the end to make it a little bit bigger. So that means when we call that create methods, 200,000 of those persons or people are created. Let's see what happened if we start that application, when we call that interface. So let's start up the application, up and running on localhost 8080. And now that's the moment where my visual VM is interesting to see what's going on my RAM. So this is the application. CPU is not that important, so I will delete this. It's more important to see what happens on the RAM side. Okay, so I will do the call on my second screen here. So I will call the localhost 8080 slash books create, right? So that was the endpoint. No, sorry, I have to double check. Lazy persons create. That was the right. Here we are. So persons create. Now you see 200,000 objects are stored to EclipseStore, to the storage. Okay, now we're getting the successfully created 200,000 in total. That means around 1.5 gigabytes of RAM usage without lazy loading. 200,000 objects in the RAM. And we could have a short look to the storage itself. So this is the storage here. And let me open this in the Explorer. So let's check what is the memory consumption on the hard disk. It's what is that here? Here we are. You see that we're talking about, yeah, around 2.2 gigabytes of data on the hard disk, and this will lead to 1.5 gigabytes of memory RAM usage on your application side. So we could do this twice and a third time and so on. You see it grows more and more. The more I click on some more data is created. Now we have 400,000 elements in the database, and it doubles around the amount of RAM. So if we could do garbage collection, so it will decrease a little bit, but I think that's quite good numbers of memory consumption, or that gives you an idea how much memory how much memory do you need for compared to the amount of data in your storage. Okay, so let's close this. Let's change the application behavior a little bit. And that brings me to the next branch. So let's stop and delete the data here. and move to the next branch. Change to lazy. Yeah, makes sense. Let's use this. So let's have a short look how the data root looked like. So this is now the way how to initialize such a lazy instance. So lazy is kind of like a wrapper object that is that wraps around the list of persons. And as I said, it's not really best practice doing it this way. I would only recommend this on bigger lists or bigger low frequented lists, I would say. But yeah, let's have a look on this. And at the same time, just adding the automatic or decrease the release time of the lazy reference manager. So normally the default one is 30 minutes, but we are able to decrease it. So, okay, so to 1 minute. And let's see what happened if we start the application again. Okay, application is up and running. So let's call that person create method. Oh, I missed. Where is it? Here is it. Okay, action is already. Okay, we are now at, yeah, around the same level. So 200,000 persons are created. And now we have to wait 1 minute and wait for the data release. So normally the finalization was here. So when we now call garbage collection, it should go down step by step. No, something. No, something is wrong here. Let me just check. It's not the way that it should behave. Something is wrong here. Disconnected. Yeah, there was the problem here. Okay. I don't know what the issue was, but yeah, let's create it again. Okay, so localhost 8080 person create. Let's enter. Okay, so data is in now. So just have 2 persons successfully created. That looks good. Now we have to wait that minute again. So after 1 minute, the data should be released. So 54, 40 seconds, 55, 40 seconds, we should be able to garbage collect. And data should be on a normal level, I have to say. 25. So give it a try. So hopefully, yeah, see that? That is exactly how it should behave. So after exact 1 minute, this data is no longer part of your RAM. And this behaves in the same way. So when we now stop the application and start it again, we would start at the same level because data stays on the hard disk. And this is exactly how it should behave after the release of that lazy functionality. Any questions so far regarding the basic lazy loading stuff? I mean, it's not that complicated. Okay, perform garbage collection. This is because of it is working kind of like at that moment when we release the data, EclipseStore works, it flags the data for can be removed if the garbage collection is running. So the garbage collector is the Java native garbage collection in the background, and it removes objects if they are flagged as can be removed. And that's why I have to press this perform garbage collection button, because the normal runtime of the garbage collection is not it's not always at the same time. So, but it can be forced to garbage collect on pressing that button. Okay, so let's move on through some more advanced examples. Change to map, and I will not start the application again. I just go step by step through the different examples. Change to map, we already, come on, okay, I see. We do not need a database inside the repository. And lazy collection, yeah. Multi-maps, that could be interesting. What's going on here? Okay. So that's why I changed this one. Okay, now multi-maps, that's an interesting so one possibility, if you do not want to use the gigamap, for example, you could use a structure like this. So you see, we have persons, or let's say people container, let's call it, or persons container. And when we jump into that persons object, it contains multiple different maps. It consists of maps by last name. So that means we have the last name here, or the very 4 digits of the last name, and then we have a list of people here, and then persons by mail, or by the very the first 4 letters of the mail. Many different possibilities, and it's the same here on that structure. The same question: does that doubles the amount of RAM? Well, not really, because the reference itself is only the reference itself is available multiple, but the object not. There is only one object for a specific person, but these are only references. Of course, also references needs RAM. That comes into play when we're talking about millions of objects. Millions of small references could also lead to a big impact on the memory side, but it's on you. And last but not least, another solution is a full lazy map, like this. This really sounds a little bit weird, or looks a little bit weird, because we are using a lazy wrapper for each person. But in fact, this is a quite good working solution, especially when we're talking about person objects with a lot of sub entries or a lot of sub objects on it. If the memory impact of a person object is quite high, then it could make sense to have that person here and maybe a combination of multiple strings to search it. Okay, but this was all these examples are all recommendations for what you can do in the future. And last but not least, because sometimes that feels sometimes kind of like a workaround how to manage it. And this was the reason why I invented the GigaMap itself. And that brings me to the GigaMap project. So, 1 second. Here we are. Let me share this as an example. So that's the example of the GigaMap. And this is working totally different. So the way how to initialize looks the same. So when we have a look here into the root itself, it looks like this. We have a GigaMap object that contains all these books. And let's say we have millions of books. So what is handled automatically in the background within that GigaMap? So first point is lazy loading is managed automatically. You do not have to care about. So the GigaMap loads chunk-wise different data to search in and so on. So this is managed automatically in the background. And on top of this, you will be able to create different indices based on that GigaMap. For example, there are normal bitmap indices like an ISBN index that I created here, or a publication date index. And on top of this, you will be able to create a Lucene index on special columns. For example, I created a Lucene index of the ISBN column. Let's jump into these indices here. This is the class I created. So this is my creator class for the indices as an example. So you see, this is the ISBN index and how to initialize it. This is the publication date index. Not that complicated, I have to say. You need to know how to do this. And these methods are returning the index. And this is an example for an created Lucene index. And it registers the Lucene index directly to the GigaMap. Then we have the GigaMap initialized. And when we jump into the data access object here, we see how it works to access all these different elements. So this is the normal query language that we provide for the normal index. So that means gigabooks.query, and then you could create your queries on that index here. So let's say is or contains and all that stuff you are aware of, the SQL and so on. This can be handled here with the normal indices, and especially for the Lucene index, you could use the Lucene API. So the Lucene string API to search within different, different objects. And best thing is, or the important thing you need to know, when you create an index based on a column or a field, then this data stays in memory. Now you might say, oh, okay, that could also lead to big issues. But the good thing is these elements are off heap. So that means at that moment, if your server is not able to handle these much memory, then it will swap that memory to your hard disk. So and with that functionality, you could handle millions of elements within your GigaMaps, but this is not, let's say, in German we say, doesn't matter, but you should not always use that GigaMap, but you could also use that GigaMap on smaller chunks of your object graph. Put the GigaMap whenever you need it, somewhere where maybe it's difficult to handle it, and give it a try. And let's start an application and see what's going on when we're creating bigger parts. I just had, this is a quite new project I created. Not sure if everything that I need is already implemented, or there is a create all that sounds okay to me, and it creates thousands of books. That's okay. Let's start this. Looks good so far. So gigabooks count. Maybe it's also interesting to see, oh, missing runtime. Okay. There is storage already available, right? Oh, yeah. Here. Okay. Okay, application is up and running. And count. Yeah, let's count this just to be sure. There is what is it? Gigabooks is called. Okay. Gigabooks count. Okay, it's a 0. Let's open the visual VM just to check how the memory behaves, and let's create some books here. It is, yeah, create underscore all. Create underscore all. Okay, books are created. And you see, yeah, not that much happens here. It must be 1,000 elements. So let me just click a lot of times here. Now, when I call the count method, we should see, now we have 13,000 elements in the GigaMap. And now that, let's do garbage collection, you see it stays quite stable no matter how much books. Oh, let me create all some more. Okay, I clicked many times. Okay, let's see. So when I create garbage collection, it cleans the RAM. So that means it stays lazy as it should. And let me check how many objects we have. Count. Now we have 30,000 objects. And now we could use some search functionality. So for example, create books. We have, let's search for, yeah, let's search term. Is it books by title? Let's search for a specific title. So gigabooks search slash, let's search for my. Let's see what happened. You see, now you get all the books that has a my into a lot of duplicates, of course, because I created always the same. But you see there is my, farewell. Let's use boy. And you see the server is quite yeah, it's not stressed, and it's really fast to get the data. This is the power of in-memory searching. But we could also search for an ISBN, right? So, search an ISBN. This is the different. Index. It's not based on Lucene. This is the normal index. A really great solution. Try it out. I sent you the example. do whatever you want and let us know your results and your measurements. From my perspective, that's a great solution, and it solves so many problems. As I said, I would not use that GigaMap always, because it's a little bit more overhead than a normal collection. And most of the time, normal collections are working great in the same way. So it's not necessary to use the GigaMap all the time. But for some situation, a GigaMap would be very helpful. Okay. So let me check your questions. Sorry, will Java then release the memory and garbage collect automatically if it needs to lazy load some different data? Yes, that's exactly what I mentioned. In the background, there is that lazy loading manager working, and it releases lazy loading objects if we reach a specific percentage of RAM memory consumption. So let's say on 75% of the memory, it starts to release objects. Did I understand it right? So far it becomes stale marked. Yeah. Okay. Could we do without indexes if we build the structure in a search-friendly tree and then iterate over small units that are loaded lazily? What about parallel streaming processing? Parallel things, especially when it comes to read something, are totally, yeah, it's okay. There is no problem on reading things, but there is a problem when it comes to read and write. So let's say 1,000 users are iterating through a collection, and one user is trying to delete one entry of that collection. This will lead to a concurrent modification exception. And this is a topic of the advanced training, how to handle these concurrent issues, because every user is working on the same object graph, right? So that's the thing. And you have to take care about concurrency. That is one thing that is important to know. It's not a problem because we could solve this, but you need to know how to solve it. But this is a topic for the advanced training. But reading things is not really a problem. On my PC, RAM, 32 gigabytes, I guess. Not sure, but something around this, 32 gigabytes. That's a good question. Let me check. RAM. 48. 48 on my PC. Yeah, it is that high because especially when we do testing for EclipseStore, we need to test it with a lot of data, and then it makes life easier having a lot of RAM. Okay, some other questions regarding lazy loading. Anything that I need to explain again, or some further more detailed questions? Okay, so let me clean up my desktop a little bit. There is a lot of stuff ongoing, and that brings us to the last, or yeah, 2 topics are left. So GigaMap example, I shared the link, right? Okay, that's okay. That's great. So then I could close this. Lazy Democrat LegacyTypeMapping. Yeah, sorry. Sometimes I do not notice it, that someone is rejoined. It does not work instantly always. So okay, LegacyTypeMapping. Also a big and interesting situation that people always ask is how to handle when data change, when data structure change. And therefore, I also brought a small presentation. And this mechanism, we call it legacy type mapping. And So what if I have to change my data definition classes? So we need to clarify, how does EclipseStore handle these data types? What happened if we do some changes in an entity? And another question is, what can be handled automatically by EclipseStore? And that is an interesting point on that topic, because we could ask the same question for any other database on the market. So that means, for example, what happened if an integer turns into a string, or needs to be turned into a string on a PostgreSQL database, for example? How could we do this? So, and this is in the same way a problem like in EclipseStore, but let's talk about this a little later. So as I said, we call this legacy type mapping, and because of that legacy type mapping, I need to, by the way, that link is not the right one. There is, within our documentation, there is a huge, just need to find that legacy type mapping here. That is a very important part of the documentation, but also sometimes a little bit confusing, and it looks like quite complicated. But yeah, let's step into this. Okay, how does EclipseStore handle data types? So that's the basic question. So what we see here is the content of a persistence type dictionary. And I told you at the beginning of the course that we could jump into such an, one moment, you could jump into lazy loading. Maybe we could see the storage here. Come on, we need one. God, let's do this like, so we just need a persistence type dictionary, and I need to check. So localhost 8080 authors create. Okay, now we should see data here. Here we are. So let's have a look into a persistence type dictionary. So this is exactly how the persistence type dictionary look like behind the scenes. And when we scroll down, you should see an object which is called author. That's exactly the author object that we have here in my domain folder. And now you see the whole structure of that author. So it's a little bit more, it's quite confusing because of mail 2, 3, 4, but that doesn't matter. The important message here is that every stored object is registered here with a given object type ID. And that makes that persistence type dictionary really, really important, because the storage itself is just a bunch of bytes, right? It's and to find out which byte belongs to what object, it's a quite important task that can only be done by this persistent type dictionary. Otherwise, you will not know when a byte starts or an object starts and an object ends, because this is calculated by this types here and the type dictionary. So try to ensure not to lose your type dictionary, because this will lead to a destroyed collection. But on the other hand, that sounds quite dramatic. But on the other hand, what happens if we delete some files of an Oracle database in the background? You will also not be able to restore it anymore. So persistence type dictionary, and it contains all the objects and the object type IDs. And this is exactly what we could see here on our presentation. This is the type dictionary, and this is how, in a way, the storage look like. Each entry in the storage has a type ID and an object ID. Each type in the storage has its own type entry in the dictionary. Yeah, and this is what I already mentioned. What data types are supported? There is a huge list within our documentation, so it's not important for now. So let's talk about customer. So what happened if we add an attribute to an existing customer? So we see that there is a customer with the type ID 66, and there is another one with the type ID 67. And this is exactly how the versioning behaves in the background. So that means when we add the IP address here, that is the field that we added. It's a string, and the name is IP address. And the Eclipse Store creates an additional type of customer. And that means whenever you touch an old version of a customer, it will be automatically transferred to the new version of that customer. So opening a customer, change something, store it, and you will store the new version of that customer. This is how the type handling works in the background. So at the beginning, we tried to work with kind of like, let's start all customers or change all customer on startup. But you could imagine if you have 1 million of customers within your storage, that is not the best way to doing that. So that's why we implemented such a versioning. And that means during the time, the more changes you have, the more of different customer objects will be in different versions within your storage. But you don't have to care. Just use it as normal, and this Eclipse Store will do the trick in the background to update it. Now the question is, what could be handled automatically? So what is Eclipse Store able to handling and matching automatically? So let's go through this example. We have a contact object here, an old one and a new one. And this is a representation of what Eclipse Store can do for you based on a heuristic which is working in the background. So Eclipse Store says, okay, there is a string, which is the first attribute of the class, and it has a name into its field name. Then it could be that this is moved, or it calculates it because first name is here, because the heuristic analyzes the whole object and sees, okay, first name is moved to the second place, and there is a last name which could be renamed because there is no last name anymore in it, and there is a string on that at the same place here, or it's moved above. You see, you get the idea. There is a heuristic that calculates all the changes that happens, and if we stay within a range of, let's say, capabilities or so, then Eclipse Store can handle this automatically. So that means whenever we change, we rename something, we move something, we add something, this is managed totally automatically within Eclipse Store, and you have to do anything on this. Let's give it a try. So let's do this. So let's delete the data here. So I prepared one starter here. So that's the master project. And when we now have a look to the author, we see there is an author. It consists of male, first name, last name. Okay, so that's the entry point. So let's start that application. There is no storage existing here. Up and running. So let's create that author. Okay, if we load it again, we should see, so author, you see that there is one object created. So mail is example.com Charlotte link. So that's the object that we have. So now we stop the application and change the branch to stage 1. Let's have a look to the author class. And now you see the changes here that are made. So we have male author instead of male, and we have first name at the same place, and last name is also changed. So what happened if when we now call the application again? So when we start EclipseStore, so then this exactly happens. So EclipseStore tells me, okay, something changed within your data structure. So there is the current type author with different fields, and it tells you author male has a chance of 70% is changed to male author. So first name 100% matching to first name, and 75% a chance of last name is matching to name. And I'm not sure there is that. Just a second, I have to move this. And it should ask you if you want to go on. And I will tell them, I will tell him yes. And no, it just printed out the result. Okay. And when we now see the result that we get, you see that it's directly changed to male author, the same storage, first name and name, like the like the new object. And this is handled automatically. Okay, now that's great, right? And to be honest, this is working really good. Even if you try to generate an error or a mismatch of things, it is quite hard to create a situation where it's not working. Therefore, I would recommend do not change many things at once. Just keep it slowly. So do it one after another. That is great. And but most of the time it's okay. But what happened if you want to define this explicitly? So not relying on that heuristic, there is a possibility, and that brings me to the documentation. Then we're talking about a file like this. There is a refactoring CSV, and that can be created by yourself. And inside that CSV file, you will be able to define what should happen with different objects and with different fields, and how should they map in the future. To be honest, I've never used this in all of the projects I've ever made. So because it was not necessary doing that. Instead of doing this, we mostly copying the storage and start up the application, transferring things or doing some business logic by copying things and so on, and then upload the storage again. So that works really great. The question is, what happens if we have to transfer data from a string to integer or other conversions? Then you will need to have business logic somewhere. This could happen within a get or set, but then that code stays in your application. It depends on you but I personally do not like this, having code somewhere that is not needed anymore because every object is transferred or so. That's why I like it to have a special class, and on application startup it transfers the data, and then I could stop the application and remove the migration code. But this is on you. For example, when we want to change, let's say, the age to a string, then I would recommend doing it this way. Create a second field, let's call it age string or whatever, and then transfer the data from int to the string field, and after that you will be able to remove the int age, for example. But this is kind of like often, let's say that is on you and your experience with EclipseStore. It works different than with a relational database, but in many cases it's the same mess of when you need to update something. Okay, so your questions. What happens when you load an old object that doesn't have a new field that was added to a new version? It will be null then, or it will be the predefined, the preset value, let's say string, and then if you add an empty string, whatever. Field initialization, there is one special situation. It is because of if you add a new collection, and this is maybe a thing that I need to explain. So let's say we adding a collection here. Let's say a new private list, for example. Yeah, let's do it like this. String list. So even if you type something like this, even if you initialize that string here, you have to check within your get or set method, because the initial return value will be null in that case. That is a special situation when you're adding a new collection to an existing storage. There are some reasons in the framework for this, and it sometimes looks a little bit weird because we would expect that this is already initialized, but at the first point when you access that list, you will get a null pointer exception. You have to prove this. You have to say, okay, if the first access to that list happens, if it's null, then let's do a new initialize the array list, and you have to store it. And after that, you could remove that type of that code. If it's just one reference here in the author, maybe. But if you have multiple authors, the code needs to stay within your get and get method, I would say. That's the only special situation handling collections and lists here. But otherwise, every other will be initialized with null, or the default value, let's say name equals, yeah, something like this, or Hans or whatever. So, okay, some other questions. How does it know the last name is changed to name? Yeah, that's part of the heuristic. Someone developed this. It was not me. I am not able to explain the heuristic that is working in the background. It's quite sophisticated code. I'm not able to understand what happens there in the background. Yeah, okay, sounds good. Yeah, of course, there is a lot of things to know regarding legacy type mapping. And yeah, that's it. Let me just check my presentation or the topics for today. Let's check if we are on track with all the different topics I want to mention. GigaMap, we talked about queries and streams. Legacy type mapping. Okay, looks good to me. We are a little bit, yeah, we are fast enough. So we have 20 minutes left, but it's good for you. It's enough time for your questions, or is there any topic you want to know except the basic stuff maybe? From my side, we touched all the topics that we need to talk about within the fundamentals training. I shared all the projects. Yeah, how about you? How about your questions? Are there any commercial training courses? Not yet, as I know. I mean, we always do commercial things for individual customers and so on, on-site trainings within their companies and so on. These are commercial things, but most of the trainings we provide here are free. So, and we have that fundamental and advanced training, and there is a new upcoming training for clustering things and so on, and how to handle EclipseStore and within a cluster with data replication and so on. So there are no books, unfortunately, but I could say that our documentation is a good and well documented document. And yeah, it's, if there are any recommendations from your side, let us know. It's open source. Feel free to use our what is the name of that GitHub? GitHub. There is a special area of GitHub discussions. So let us know. As I said, it's open source. Contribute stuff is important for open source. Resilience. Can you say something about resilience? Okay, when we're talking about resilience on that level that we talked in the fundamentals training, so then I would say, it's quite hard to damage the storage. When it comes to Kubernetes, there are some edge cases that could harm the storage itself, especially when we're talking about things like accessing one storage from multiple instances. So this is an absolute no-go, I would say, because do all that housekeeping stuff and storage, garbage collecting, and so if two application accessing the same time, this could damage the storage. So be careful of this. Otherwise, so when we're talking about resilience within a cluster, there are so many different situations that could happen. It's hard to say how resilient it is, but you always have to keep in mind that when we're storing things to the hard disk, then the way from RAM to hard disk or the application, so there is no remote connection in between storing things and reading things, and that makes EclipseStore even more resilient, because what could go wrong? There is maybe one situation where a persistent volume can be unclaimed or detached or whatever. That could happen. And in this case, you should immediately shut down the application, because this is quite, let's say, this is a dangerous situation, because when we're talking about memory editing and so on, your users will not notice at the first moment that EclipseStore is not storing anymore, because when you call a store method, then the user is editing the RAM, and if there is no try catch or something in between, or even there is a try catch, then you will get an exception right in your logs, but you will not notice right now that something is wrong. So at that moment, if storing is no longer working, you should immediately shut down your application, because users are working again and further, and at the end, when you restart the server, all the data will be gone. So that is one hint that I could give you. Normally, that is a point for the advanced training. When it comes to more advanced infrastructures. So, but yeah, the storage itself and the framework itself is, I would say, very resilient. Yes, it does provide metrics. I mean, there is an basic there is an implementation of Java JMS. Is it the right word? JMS, JSM, JMS, Java metric system. It's implemented, and most of the frameworks are able to monitor EclipseStore, how it works, how many objects are in the system, and so on. And of course, there is a documentation regarding that. That does work quite well. JMX, that was the right. Thank you. Java metrics, right? Is the okay. By the way, the next training, the advanced training, will be, let me just check. I need to double check. So yeah, EclipseStore Advanced, 9th of December. December the 9th. The 9th is next advanced training. And then in that advanced training, we are talking about yeah, all that, so exception handling, concurrency handling, some more advanced topic about, yeah, what is how to handle the housekeeping process, what is important to know regarding the housekeeping. There are some different settings on the housekeeping, and some further advanced topic, 9th of December. Same time, from 5 to 9. It will be free as well, yes. Is Eclipse serialized depending on Java serialization? No, it's a totally from scratch invented serialization. That is also the reason why Marcus said it's way more secure than the basic Java serialization, which is by far not secure, but it's totally an own invented serializer. So that means our serializer is not calling any constructors and so on. So it's totally based on own invented, I think. Okay, so great. So if there are no further questions, so I will stay a little bit longer in the meeting. So, but yeah, then I would close the session, and let me say thank you, and thanks for joining, and thanks for your attention. Hopefully that was interesting for you. You learned a lot. Feel free to try it out. It's a great technology. Let us know if something goes wrong and if it's not working as expected. So there is GitHub discussion. Please think about to register for your certificate on our cluster platform. So use the same email address as you used for taking part this training. Yes. So let me just check the documentation. Maybe they are listed in the documentation. And that also might change, because I remember some objects like, what was it? Stuff like serializable or really weird stuff, which was not supported because of thing. But let me just check the documentation. And we also fixed a lot, of course. So storage. So I found one list, which is, let me share my screen again. Here we are. Okay, this is the list of supported Java features. It's in the addendum. These are all the supported things. So you could see these things here, like static fields, And it's also based on the different Java versions here. Yeah, for example, this one, lambdas are not handleable in theory. Records are supported on Java 14, immutable sets, immutable lists. Yeah, that's the only thing I could provide for now. Type handlers. These are all the different types that can be stored, all the different collections. Maybe there is also a list of non-supported things. Okay, it depends also. Then you need, maybe you need that binary JDK here for thing, but that is moved also to the newest version. Yeah, a lot of stuff, but this is the only thing I know so far. I hope that helps a little bit. Yeah, many thanks to you. Have a good time and enjoy.